So these are similar in space. I'm just going to draw them as though we're looking head-on to the values of the vectors. So question number 1 just wants to know what is the angle between the two vectors. So how can we find the angle between vector A and vector B? Yeah.
Inverse cosine of A dot B divided by the magnitude of A times B.
Right, so that first equation we looked at was the only one that had that angle directly involved. Now, honestly, we're not going to use this use of the dot product too much in this class, but it is useful in other applications. So we want to use this version of it. So A dot B was the magnitude of vector A times the magnitude of vector B times the cosine of the angle between those vectors. So what we need to find is this theta AB here. But we need to get all of the rest of this stuff so that we can find that unknown. So let's start by finding the left-hand side here, A dot B. So how do we calculate A dot B?
Multiply them together someday.
Right, so we multiply them, again, in a specific way. To find the dot product, once things are in component form, we multiply the like coefficients and add them together. So looking at let's start with the coefficients of I. We have -1 and 1. So -1 times 1. Please note somewhere that this I'm indicating as multiplication for this x. When we do cross product, it's going to look the same. So this is a multiplication for this step. So -1 times 1 plus 8 times 18, the j components, plus the k components, 4 times -6. And also notice here there's no i's, j's, or k's. These are all just scalar values. So -1 plus whatever 8 times 18 is, minus 24 will give us a value of 119. So 119 is the dot product of A and B. All right, so that's our left-hand side. We need magnitude A. So how do we calculate magnitude of A? Right, so distance formula, basically just of the components of A. So it's going to be the square root of the sum of the squares of the components of A. So that's going to be 1 squared plus 8 squared plus 4 squared. Again, this is a very nice example because all the numbers are going to be nice and round. In general, it won't be. So 1 plus 64 plus 16 is going to be 81. So square root of A1, and this works out very nicely so that the magnitude of A is 9. Same thing for B. Its components are 1, 18, and 6. So this works out nicely to 19. So we have A dot B, we have magnitude A, magnitude B. Finally, we can find what we were looking for, the angle between these two vectors. So 119 is equal to 9 times 19 times the cosine of theta AB. Divide through by 9 times 19. We're going to get 0.696 is the cosine of theta AB. Take the arc cosine of both sides. We get 45.9 degrees. B, find the magnitude of A in the direction of B. So we are finding, what that means is A parallel. So what's the magnitude of the vector, the amount of A projected onto B is what we're trying to find here. So looking back a couple of slides, A parallel, magnitude A parallel was vector A dotted with the direction of B, not B itself. So this is given to us. We have to find U hat B. So how do we find the direction of B? Yeah. Right, so this is the same as normalizing B, or taking B and dividing it by its own magnitude. So we actually already know its magnitude from the previous step. And B is just going to be I plus 18J minus 6K. So these come out to be nice numbers. 1/18 I plus 18/19 J minus 6/19 K. This is a unit vector. It has no units associated with it. It's a dimensionless quantity. Again, if we check this, we should get that the magnitude is equal to 1 of this thing. A was given. We just found U hat AB. We can now find the magnitude of A parallel. So that's going to be negative I plus 8J plus 4K dot U hat B. I won't rewrite it. This is a vector. This is a vector. Our result will be a scalar value. So to calculate this, we multiply the like terms, add them together. So we have negative 1 times 1 over 19 plus 8 times 18 over 19 plus negative 4 times negative 6 over 19. So multiply this, add them together. A parallel is 6.26 newtons. Vector A has units of newtons. U hat is a unitless quantity, so we multiply newtons by a dimensionless quantity, we end up with newtons again. Part C, though, asks if we want the components of this, so we want to describe this as a vector in component form. So now we're looking for, in part C, a parallel vector. So we just take the magnitude, which we just found, and now we multiply it by U hat B. Here we had to dot them together. Here we're just multiplying them together. So this is going to be the 6.26 newtons times, well, U hat B. Again, I won't rewrite it. So it's a scalar times a vector, which gives us another vector here. So it's 6.26 times each of these components. So 6.26 times 1 over 19 gives us 0.33i. 6.26 times 18/19 gives us 5.93 in the j. And 6.26 times negative 6 over 19 gives us negative 1.98 in the k. And again, this also will have units of newtons. We're expecting a vector. We have a scalar times a vector, and we do indeed have a vector because it has I, j, k components, and it again carries the units of a parallel. This was in newtons. This still was in a dimensionless quantity. Questions on part C? All right, so finally, find the vector of the perpendicular component. So we know how much was along B, so we want to find how much is orthogonal or normal or perpendicular to B. So this is where we use that last relationship where what are we doing? We're decomposing our vector into some amount along a direction and then some amount perpendicular to that direction. Again, very similar to what we did last week with the XY coordinate system. This is just a different coordinate system is one way to think about it. So A, vector, is its parallel component plus its perpendicular component. So it happened that last week in 2 dimensions, the parallel component only had I component, and the perpendicular component only had J component. Here, because we're not looking at how much is in the XY, but how much is along B, each of these can have I, J, well, it's also in 3D, I, J, and K components for each of them. So, what do we know? We were given A, we just found A parallel. This is what we're looking for in this question. So we can rearrange this, that the perpendicular is going to be A minus A parallel. So, lastly, we were given what A was, negative I plus 8J plus 4K minus what we just found, 0.33I, 5.93J, negative 1.98K. We're just subtracting vectors. Negative 1 minus 0.33 is negative 1.33I. 8 minus 5.93 gives us 2.07J. And 4 minus negative 1.98 is the same as 4 plus 1.98. We get positive 5.98 K, and this is also measured in newtons. So again, this is the vector A perpendicular.